Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Today we will be looking at the second part of rule model, that is algorithm part. Right. So right, we have already developed a rule. This is a rule. Why I say this is one rule? Because if gills is equal to yes, then class is equal to negative. Else if teeth is equal to many, then class is equal to positive. Else, if length is equal to 4, then class is equal to negative. Else class is equal to positive. That is, if this happens, else. There are no rules here. No, this is not rules list. This is just one rule. One rule. This is not a rules list. How do we convert this into a rules list? Let us see that. Right. Organizing rules in a list is one way of dealing with overlaps among rules. See, we want to have, see, this is one rule, but we want a list of rules, my dear friends. If observed the previous condition, we can say that they are not rules. It is only one rule. It has an order. Order. What is the order? Now, first it checks gills. First it checks gills. And then it checks teeth. So this is the order. Now, alternatively, we could write the rule list such that rules are mutually exclusive. That means, no, you can execute whatever the rule you want. So there is no order. Such is called mutual exclusion. This is useful because it means that we can use each rule without reference to the other rules. Now here, if you see here, this gills is equal to yes, then class is negative. Else, that means this will be executed only if this gills is not S. This rule is limited with this rule. So no, without reference to the other rules, and also ignore their ordering. So this is what the ultimate goal of us. Now, the only slight complication is that we need negated literals for those features that have more than 2 values such as length. Negated literals or internal disjunction. So we already have learned this internal disjunction in the concept learning class, concept learning chapter. Okay, very simple. This is not difficult, right? Anyhow, we'll see that. See, a slight variation for this is written here. If gills is equal to yes, then class is equal to negative. This is the first rule. If gills is equal to yes, then class is equal to negative. The second rule is, there is no else part, my dear friends, here. There is no else part. If gills no and teeth many, then class is equal to positive. This is the second rule. Similarly, if gills no, teeth few, and length is equal to 4, then class is equal to negative. This is the third rule. And if gills is equal to no, and teeth few, and length not equal to 4, then class is positive. This is the fourth. Oh, so we have created now 4 rules. 4 rules. No, if you no, ఏ రూల్ అయినా ఈ 4 rules లో ఏ రూల్ అయినా సరే ఫస్ట్ అయినా తీసుకోవచ్చు, సెకండ్ అయినా తీసుకోవచ్చు. ఎనీథింగ్ క్యాన్ బి డన్. So such is called rules list. This is called rules list. Rules list and list of rules. List of rules. Now let us learn. Let us learn how do we convert a rule like this. If P and Q, then class is equal to positive. Else, if R, then class is equal to negative. How do we convert such type of a single rule into rules list? We wanted to make these mutually exclusive. The second rule would become like this. If not of P and Q and R, this happens. Positive, negative ఎప్పుడు happen అవుతుంది? If ఇది else అవ్వాలి, దీనికి else part అవ్వాలి. What is the else part of P and Q? Not of P and Q and R, then only this becomes clause negative. Such thing is called as similar. Or in other cases, if we apply De Morgan laws onto this, De Morgan laws మనం apply చేస్తే this becomes not P or not Q, not P or not Q, and or, then clause is equal to negative. This is how a single rule which is having else part can be converted into rules list. Rules list. This is how we can convert a rules list into a rules list. Hope you understood, my dear friends. This is important. This is what you have to write in the examination. This is what you have to write, you have to explain, right? Hope you understood. Right. Now let us go to what is called algorithm. Algorithm. In the tree model, we have created an algorithm for tree building. In the same way, we have to go for an algorithm for learning or creating a rule list. Right, algorithm learn rule list is our algorithm name. Specifies the separate and conquer rule learning strategy in more detail. Our strategy is separate and conquer rule. Separate and conquer rule learning strategy, right? While there are still training examples left, now our algorithm makes, you take one rule and you delete the training examples which are covering this particular rule. So remaining rules are there. Do you understand, my dear friends? So the algorithm learns another rule, removes all examples covered by that rule from the data set. This is also called as covering algorithm. Covering algorithm. Covering algorithm. My dear friends, let me tell you again. Whenever we find a rule, ఆ రూల్ కలిగి ఉన్నటువంటి అన్ని ట్రైనింగ్ ఎగ్జాంపుల్స్ ని మనం మన సెట్ నుంచి తీసేస్తున్నాం. We are going with remaining rules only. We are not bothering about the covered rules. That is only called, this algorithm is also called as covering algorithm. Covering algorithm. See, normally it uses the two functions, namely homogeneous of D, tells whether D is a homogeneous or not. What do you mean by homogeneous? Homogeneous means, so homogeneous means similar data type, similar, or we have reached to the end, something like that, which cannot be furtherly divided, not necessary to divide further. It's called homogeneous. Let us assume that homogeneous is a function. Homogeneous is a function which tells you when we send a rule to homogeneous. Homogeneous is a function. We transfer a rule to homogeneous. When we pass D as a parameter to homogeneous, it tells us whether this is the last one or similar one or not. This is homogeneous function. Similarly, label of D is another function where label, I'll pass parameter D to label, which decides whether further specialization is needed or ఒకవేళ ఇంకా ఏమైనా specialization కావాలా, else what class to put in the head of the rule respectively. So this is what homogeneous specialization ఏమన్నా కావాలా అనేది చెప్తుంది, and label D decides what class to be placed on the head of the rule. Head of the rule lo em place cheyali. This is called homogeneous and this is called class. So let us assume there are two functions, my dear friends. One is homogeneous, another one is label. Homogeneous function, when I send D, it tells me what the content of homogeneous is. We are not bothering about that. We take it for granted that homogeneous is a function available. We pass D and we get whether D can be furtherly divided or need not be divided. Something like that, it gives us information. Similarly, label of D is another function. If I pass D, it automatically gives me the class name. So these are the two assumptions we have. So in the same way as label tree decision tree slow madrigane, it employs a function called as best literal DL. Best literal DL that selects the best literal to add to the rule from the candidates in L. L means the list of literals given data D. Okay, data D ఇవ్వటానికి L ఎన్ని literals అయితే కావాలో ఆ literals అన్నిట్లో which one is the better literal to add. Hope you understood, my dear friends. Literal is length is equal to 3 is literal. Hope you understood, right? Let us go for the algorithm, right? Learn rule list D. See, what is the input? Labeled training data D. Labeled training data. What we get? Rule list R. Rule list and right. First, initially, we say R is equal to empty. And we repeat until D is, see, D is not equal to empty. While means while false exit. So when eppudu idu exit avutadi, when D becomes empty, it comes out. When D becomes empty, remember, my dear friends, in our rule learning, whenever we add R to learn rule is another function. Shortly we will be learning that also. It gives you a R, a rule. Learn rule for D, for this data, learn a rule. So it gives us a rule. Now append that R to R. Now D, subtract this D from, see, ఏ రూల్ అయితే మనం ఆర్ లిస్ట్ కి యాడ్ చేసామో ఆ రూల్ లో నుండి డి డేటాని తీసివేయండి. దిస్ ఇస్ వాట్ ఇట్ ఇస్. రిమూవ్ డేటా. నౌ రిపీట్ దిస్ until D becomes empty. See here, very simple, my dear friends. First, R is equal to empty. Now first step is or small r is equal to get rule or learn rule of D. Learn rule of D. Append it to capital R. Append it to capital R. Remove D from D. Remove the data from D. That's it. Repeat this until D becomes empty. As simple as this. This is learn rule list. And we have to learn this learn rule. Learn rule. Let us learn that also now. Right? Learn rule. Learn rule. See, it is learns a single rule. Labeled training data D. One data is something. One datum, you can say. See, I'll give you one. See, it gives us rule R. Let B is equal to true. Let B is equal to true. L is set of available literals in this particular D. D, set of available literals, all literals, while not homogeneous of D. And for example, if you take a rule like this, so it is consisting of length is equal to 4 and gills is equal to no, back is equal to S and teeth is equal to many. Now it can be furtherly divided. So it consisting of many rules, many literals. Now homogeneous, while not homogeneous. If homogeneous, come out. If homogeneous, this comes. If homogeneous, come out. That is the meaning. Now, if not homogeneous, L is equal to best literal D comma L. This is an assumption again. We feel that best literal is a function that takes D and capital L, set of literals, my dear friends. That gives me the literal which is the best suited. For example, in our case, see, gills is equal to no, teeth is equal to few, length is equal to 4. So, ilanti anni literals ganaka unte, whichever the literal, suppose if this function finds teeth is equal to few is the better literal, it gives me teeth is equal to few. As simple as that. Now what we do? We just AND this particular literal with B. Now we delete that particular literal from our D. ఇప్పుడు కవర్ అయిపోయింది కదా, సో ఆ literal ని మనం తీసేస్తాం. And we see this also now features list లో నుంచి కూడా set of available literals నుంచి కూడా మనం దాన్ని తొలగించేస్తాం. Now we'll repeat this again. Very simple and very simple. The main part of this is add. So you have added, so you can remove. Add or remove. This is add, remove. Add. Where do you add? See, here you are adding. This is called addition. And where do you remove? This is remove. ఎక్కడి నుంచి D నుంచి తీసేస్తున్నావు మరియు L నుంచి తీసేస్తున్నావు. And again you are going back. So this is how it goes. So this is finally C is equal to label of D. We are calling the function label of D because it is homogeneous. ఇక్కడికి వచ్చిందంటే అర్థం ఏంటి? It is D is homogeneous. So it gives you a label. So now we say if B, then class is C. This is the rule sent back. So very simple algorithm. let me just explain you again. See, right, this is very simple, right? We say R is equal to empty, rule list is empty, and we just get one rule from another function called learn rule, and we just append it to our rules list, and we just remove it from our D. That's it. There are only 3 steps: first, second, and third. Get a rule, get a rule, append, remove. As simple as this. Very simple. Get a rule, append, remove. And here it is also very simple, my dear friends. It is also very simple. See this. Let B is equal to true. Let L is set of all available literals. Now, while D is not homogeneous, do the following. L is equal to, we are assuming here, best literal D comma L. Best literal D comma, it gives us, if I pass D and L, list of all literals, D comma L, it gives me the best literal. We are adding that best literal to the rule. Just true and L. What do you mean by true and L? True and L. True means 1 and. See, if you take 1, 0, the answer is 0. 1 and 1, the answer is 1. That is, if in true case, if 1 is true, the result depends on the other one. See, if this is 1, the result depends on ఇది ఏదైతే ఇది 0 అయితే ఇది 0 అయింది, ఇది 1 అయితే ఇది 1 అయింది. అంటే 1 and see L always gives you L. So this is called true. So we are just adding. We are adding the L to the rule position. Now we just delete that particular literal from D. అదే విధంగా లిటరల్స్ లిస్ట్ లో నుంచి కూడా ఆ లిటరల్ ని డిలీట్ చేస్తున్నాం. Now after finding that the D is homogeneous, we are just calling the label function, and we are getting its label C. Now we are forming now the rule. Etla, if B, see, the B contains the conjunction. The B contains the conjunction. If B, then class is equal to C. This is what we are sending back to the rules list, the learned rule. This is how rules list algorithm works, right? Anyhow, so if you see here, now A, gills. See, the first rule apply. So if I apply the first rule, it gives me the gills. Right. In this function, so I applied this particular rule. It gave me gills. For suppose, best rule, gills. There is one S and there is not S. Not S. S means B0, B, all negatives, pure negatives. 0, 4. So negatives. This is how it covers. All negatives. Suppose if it is not yes, that is gills no, then we check teeth. Teeth, many or few. If it is many, then we come and end with pure D and D. This is pure D. This is pure D. This is pure D. Similarly, if not many, few, and now we are checking length. If length is equal to 4, it is negative. If length is not equal to 4, whether it is 3 or 5, we say it is Z. So this is G. This is again a positive. So all leaves are now pures. All leaves are now pure. Now if you consider C, what is C here? C has both negatives and positives. So C can be placed here. This is A. This is A. If you see D and pures, D, B, D, A, G, so easily we can place. F, if you see, this is, see, it covers 0 positives. Kabatti, here we have mentioned it as F. F. Similarly, if you see B, B is, see, this is B completely. It can also be represented here. Now E, where is E? This is E. This is E. Similarly, this is F. This part, and this is G. And this is the part where D comes. This D comes here. So this is how the coverage graph also can be shown. So this is our rule model. Now, how do we, now this is the concept of algorithm. Learn rule list algorithm. Learn rule list algorithm. Learn rule list algorithm. Now, this is also called as covering algorithm. Covering algorithm. Covering algorithm. Separate and conquer rule learning strategy. Right? Right. Next, let us go ranking and probability estimation. How do we do ranking and probability estimation? Consider the following two concepts. If length is equal to 4, whenever we say this, P2 comes into consideration, and N2, N4, N5. So totally this covers N2, N4, N5, 4. 4 of our training set. Now, if I say bake is equal to yes, it covers P1 is equal to 5. P1, right, positive 1 to 5, all 1 to 5 are being covered, and it covers N1, N2 plus 1. That is totally 8. It is covering 8. And this covers 4, this covers 8. Now, let us write a rule. We construct a rule list AB like this. If length is equal to 4, class is negative. Because out of 4, 1 is positive. Out of 4, 1 positive and 3 negative. So more negatives are there. Kabatti, let us write this as negative. Now coming to the else part. Else part. So else part వచ్చేయటం తోటే చూడండి ఇక్కడ 8 కాస్త 8 ఉన్నాయి యాక్చువల్గా. సో ఇక్కడ 3 పోయినాయి. కాబట్టి we are left with only 5. Because see common P2 పోయిందా, and ఇక్కడ N2 పోతుందా, and 4, 5 కూడా పోతుంది కదా. So in that way, so we are reduced here to 5 only. Four positives and 1 negative. 1 negative. See, P1, P2 పోయింది కాబట్టి 4 positives అన్నాం. ఇక్కడేమో N2 పోయింది కాబట్టి N5 కూడా పోతుంది కాబట్టి we say only 1 negative. If bake is equal to yes, then class is equal to positive. ఎందుకు 4 positives are there. Else class is equal to negative. In all other cases, this is we'll be left with only one. See, so kabatti we are saying this. This is one rule. This is one rule. Now coming to the same thing, same. Dinne inkoka rakanga kuda project cheyochu. What is the other way? See, we can also construct a rule list in the opposite order, BA. If bake is equal to yes, then class is equal to positive. At last, student, we have taken the second one first. If bake is equal to yes, there are positives, 5 positives and 3 negatives. We are saying that. See, if bake is equal to yes, then class is equal to positive 5 plus 3 minus. Else, if length is equal to 4, if length is equal to 4, then class is negative. Else, class is negative. This is a, so now there are two rule list, my dear friends. This is a single rule. This is a single rule, and this is a rules list. Which of these rules lists the better rank? This is the question. Now, definitely by looking at, see, we can see that AB makes fewer ranking errors. Ranking errors would be very few, and BA than BA, my dear friends, and thus has better AUs. So we say AB makes fewer ranking errors. So we say AB is better than BA. If accuracy is our performance criteria, AB would be optimal. Right? Now, this is how ranking is derived. Rule lists produce probabilities that are well calibrated on the training set. This is the conclusion. Rule lists produce probabilities that are well calibrated on the training set. So this is what is rules list, and this is ranking and probability estimation. Let us now conclude. So we have taken, today we discussed what is called a single rule, what is called a rules list, what is called a rules list, right? So how to convert an else part, a rule with else part into a rules list with an else part into mutually exclusive rule, mutually exclusive rule. And then we learned what is called covering algorithm. Covering algorithm, this is nothing but add, remove, add, remove, add, append, remove, add, append, so get rule, append, remove, get a rule, learn rule ద్వారా rule వస్తుంది మనకి R లోకి, and append చేసేదాన్ని and remove that. That's it, as simple as this. In the same way here also, L is gives us best literal, add that literal to B, and then delete that literal from D as well as L. So after that, after finishing, after finding D is a homogeneous one, and call label function to call label function with D so that it gives you a name, a class name, and then you form a rule like this. If B, then class is equal to C, that is sent to R, that is returned. So this is called algorithm, right? Now, what is called ranking and probability estimation? Ranking and probability estimations. If you have a small, consider a concept, two concepts called as length is equal to 4 and bake is equal to S. Now, by looking at, now we can have two models for this. This is one model, and the other model is, this is the other model. Now, how do you say which model is better? How do you say which model is better? No, performance criteria తీసుకుంటే AB would be better. So AB is better than BA. So this is how it is. But finally, rule lists produce probabilities that are well calibrated on the training set. This is it for today. Thank you.